Imagine you're building an e-commerce site. Every e-commerce site needs to show the average rating for each product when displaying search results for products. You might do this by calculating the average rating for every product on the fly every time someone visits the page. However, this would cause unnecessary overhead on the server and database because you're constantly recalculating the average ratings. When faced with situations like this, and given the fact that the frequency of writes are typically orders of magnitude lower than the frequency of reads, a better solution is to pre-calculate certain fields during writes rather than reads, thus saving you time and overhead during reads. This is called the aggregate pattern, also known as the computed pattern. In our e-commerce example, you can store the number of reviews as well as the sum of ratings within each product's document. When a new review is added, you can increment the number of reviews and add the new rating to the existing sum of ratings. Then, when a customer searches for a product, you read the sum and the count of ratings and calculate the average on the front end by dividing the sum by the count. This way, every time a customer visits the page, the server and the database only need to return the pre-calculated values, resulting in improved performance. Let's see what this looks like in code. Here, I have imported redis-om for Node, and I'm using it to talk to Redis Stack. Using redis-om, I'm modeling products with a name field. I also have product reviews with a product ID, author, and rating field. In order to add a new review, I simply create it and save it to Redis Stack. However, it's fairly complicated to get a list of products with the number of reviews and the average rating. Redis Stack has a built-in FT.AGGREGATE command that allows you to perform aggregate queries very easily. We'll use it to group by the product ID and perform a reduce to calculate the average rating and count of reviews. Using redis-om, I can get all the products and use the product review index to run the FT.AGGREGATE command and return the average rating and number of reviews grouped by product ID. Then, I can extract the average rating and the number of reviews and map them to the product entities, and then return the result. The problem here is that this needs to be run every time a customer visits my site. This can lead to needless overhead. Instead, let's look at a better approach that uses the aggregate pattern. Once again, I'm importing redis-om for Node, and this time I'm modeling products with a name field, num reviews field, and a sum ratings field. I also have product reviews with a product ID, author, and rating field. Using the aggregate pattern, every time I want to add a review, I need to fetch the product from Redis Stack, increment the number of reviews, add the new rating to the sum ratings field, and save the product as well as the new product review back to Redis Stack. While this might seem cumbersome, keep in mind a typical application has far fewer writes than reads. So what does it look like to get all the products when using the aggregate pattern? Well, given that we already have the sum ratings and num reviews pre-calculated, all we need to do is return the products directly from Redis Stack. So while there's some additional work at write time, we've greatly reduced the work necessary at read time. Now let's see what this looks like in Redis Insight. First, let's see what it looks like when we don't use the aggregate pattern. Using Redis Insight, you can filter to only products, and if you look at a product, you'll see that it only has the name field. If you remember back to our code, we had to perform the ft.aggregate command in order to get the number of reviews and the average rating. I'll use the CLI that's built into Redis Insight to run that command. You can see that it gives me all the products, and for each product it gives me the average rating and the number of reviews. Now let's see what it looks like when we apply the aggregate pattern. I've refreshed the data in Redis Stack to follow the aggregate pattern, and now when we filter to products and look at a product, you'll see the number of reviews and the sum of ratings fields. Since we can calculate the average rating by dividing the sum of ratings by the number of reviews, we no longer need to run the ft.aggregate command, thus saving us overhead when getting all the products from Redis Stack. When building read-heavy applications, consider using the aggregate pattern to reduce the overhead necessary at read time when calculating aggregate information on the fly.